Okay, welcome back to another video. This video is a continuation actually of the previous video that we did, because the previous video we did about the reactivity series. We became familiar with a very new topic, which was the reactivity series, where we saw the reactivity of certain metals in the periodic table. So with that in mind, now we come to a new chapter, which is we want to know how certain metals, or maybe, yeah, we do a certain, how certain metals in that reactivity series we are able to extract and use them as metals for our day-to-day needs, because those metals that were discussed in those in that reactivity series is very, very important into our day-to-day life. Okay, so we'll in this chapter we'll be discussing basically we'll be discussing different techniques that we use to extract these metals in that reactivity series, and also we'll be discussing a feature or an application with regard to this reactivity series, which is rusting. And also a very new term we'll be discussing, alloys. So by the end of this video, you will be knowing all of these different new things that we are going to learn. Okay, so in the different techniques, we will be looking in detail only into two extraction methods, which is one extraction of aluminium, and the other one is extraction of iron. All right, so let's move on. So the important thing is, okay, now you would wonder, why do we need to extract these metals? Like, don't these metals exist in the nature? Yes, they do exist in the nature, but they do not exist as metals in the nature. Okay, they exist as metal compounds, or maybe a mixture of metal compounds. So what are metal compounds? So metal compounds are basically, they will exist as metal oxides, metal carbonates, metal hydroxides. So basically, they'll be existing as a mixture of different metal compounds rather than the metals itself. So when they exist in that form, we call them as metal ores. Okay, so in nature, you do not find metals existing as metals, but you see them exist as metal ores. All right, so our task is find a method to extract these the metal from this metal ore. So basically, from a metal oxide, we want only the metal, because the metal is the thing that we'll be using to that we will need in order to accomplish our daily tasks. All right, so that's the whole point of the meaning of this entire lesson. Extraction means that. So why are we extracting? Because in the nature, metals do not exist as metals, they exist as ores. What are ores? Ores are different mixtures of metal compounds uh, that exist in the nature. All right, so let's move forward. So this is a reactivity series. Okay, so now we know this reactivity series, the elements that are on top, right? So basically this in the decreasing reactivity order. So basically the one on the top is the most reactive, and the one at the bottom is the least reactive. So due to this reactivity, the technique we need to apply to extract these metals are different. All right, so for example, from elements from potassium to aluminium, okay, if you want to extract the metal, we need to perform an extraction method called electrolysis. All right, electrolysis is a method that we will perform in order to get the metal. All right, then there is another set of elements starting from carbon to hydrogen. These metals can be extracted by heating it with a reducing agent. All right. So in most cases, you will see carbon is used as a reducing agent, or else carbon monoxide could be used as a reducing agent. All right. And the other portion of elements will be varying from copper to gold. These metals can be easily extracted. They don't need any technique. You don't need to use chemical technique, chemistry. You don't need to use. You just need to use your common sense and then just go and hand pick. So, for example, if you listen to the news, you will see people uh, hand picking gold. You don't need to use big Bunsen burners and everything and go and extract gold. You can just go and hand pick gold. Okay, why is that? Because uh, elements from copper to gold, we know that they are least reactive, so that's why we are able to do that. All right, so let's move forward. Okay, so this is the first part that this is one of the most important things that we will learn in this is extracting iron. I told you that we will in detail we will learn about two extracting methods, which is extraction of iron and extraction of aluminium. So here we go, extracting of iron. That's the first part. So this extraction of iron happens in a structure called the blast furnace. This is a very big structure. Okay, so this is the drawing of the structure. You will find this in your textbook also. Okay, so this happens at very high temperature. These temperatures, usually it varies from 200 to 1900. So very high temperatures these happen. So what happens in this is few reactions take place. For example, first of all, we actually put certain contents into this blast furnace, and based on those contents that we put, they will react with each other, and they will uh, give us our final product which we want. Which we want is actually iron, right? So iron we are able to get at the end of this entire process. So we look into all of those. Okay, first of all, now I said we have to put some contents into this blast furnace. So the contents we put is, we put iron ore. Now, why do I say iron ore? I normally say in nature we cannot find uh, pure iron. That's why we are doing this process. So we have to put an iron ore. More specifically, when we say in this process, we put the oxide of iron. So basically, we put iron oxide. The chemical name for iron oxide is hematite. Okay, maybe there are different ways that you will use to pronounce, maybe hematite or something like that. Never mind, who cares, right? As long as you know that it sounds something like that, that's okay. Okay, so hematite is iron oxide. That is the iron ore that we're using. Then limestone is in the chemical name for limestone is calcium carbonate. Okay, so calcium carbonate. So limestone means limestone, you would see limestone buildings are there. Most of the statues are made out of limestone. Okay, and then we are used, the third content that we are adding is coke. It's not Coca-Cola. We are not adding Coca-Cola to this. Coke is a chemical, another name that you can give for carbon. Okay, so we are not adding Coca-Cola, we are adding carbon. Be very mindful. Okay, so these are the three contents that we are adding, and these will react. These will produce few reactions, undergo few reactions, and give us the desired product. So let's look into that. So the first reaction is, we will see the carbon or the coke that we add will react with the oxygen to produce carbon dioxide. Okay, and the carbon dioxide as a next step will react with carbon, okay, or the coke, and form carbon monoxide. Now you can see in that reaction, carbon and oxygen, when carbon dioxide is formed, it is a oxidation reaction, because carbon, you can see carbon is getting oxidized, and it gets oxygen, right? So adding of oxygen or gain of oxygen is oxidation, right? But if you see in the next part, in the second uh, uh, reaction that is here, carbon is being reduced to carbon monoxide. So carbon is the reducing agent. Okay. So if you remember in this video at the start, I said that there is a portion of elements that will undergo that we need to heat with a reducing agent to get the desired metal. So this is one example. So you see we are heating it with carbon. Okay. So step 3. Now we have obtained the uh, these two we discussed about these two reactions. We'll go to the third reaction, where we see the iron oxide or the hematite or the iron ore is reacted with carbon or the coke to form iron and carbon dioxide. So what has happened in that reaction? Let's see. Because we have the symbolic reaction also. We can see that the iron oxide is being reduced to iron. All right. And the carbon has been oxidized into carbon dioxide. So in that case, in this reaction, carbon acts as the reducing agent, whereas iron oxide acts as the what? It acts as the oxidizing agent. All right. So be familiar with these terms: oxidizing agent, reducing agent. We discussed it in the previous video also. All right. So as a result, this uh, uh, reaction is able, we are able, with this reaction, we are able to get uh, the desired metal. But in case of uh, say in case of, say, we don't have much oxygen, okay, or something like that, or maybe due to this high heat, we can also use, like, from this reaction straight away, we can use this carbon monoxide, and then it reacts with iron oxide to form this iron and the carbon, and that's also a possible reaction. So these two, this reaction and this reaction, either of them is correct. Okay, so either of these is correct. In this, carbon is the reducing agent. In this case, carbon monoxide is the reducing agent. All right. So these are the reactions, okay, that you need to be very familiar with when they are asking questions about this. Because if you see your past papers, when they want to question you about this blast furnace, they will always say, write down the reactions involving in the blast furnace. So if you know these reactions very clearly, crystal clearly, with state symbols and all of that, then you are able to obtain full marks, which is a very easy task, right? Just understand what's happening here, and you are able to get the full marks. Now, the other point is, now we discussed about, now out of the 3 contents that we added to his blast furnace, we discussed about the coke and also about the hematite. But so what's the purpose of the calcium carbonate? It has a purpose. We have a purpose of it. Calcium carbonate within the blast furnace will thermally decompose into calcium oxide and carbon dioxide. What does it mean by thermally decompose? That means calcium carbonate with heat will break into 2 new products, which is calcium oxide and carbon dioxide. What is the what's the purpose? You will ask, what's the purpose of this reaction? There is a purpose, because this calcium oxide, if you react it with this silica, which is SiO2, or in other words, simple word, sand. If you react that two, you are able to get a product called calcium silicate, which is used to make road surfaces. Okay, so that is very important. So the important feature of this blast furnace is not just getting iron, but also you are able to get this calcium silicate. It is a very useful. Uh, it is very useful in making road surfaces. All right. So be very mindful of this reaction also. Okay. But in with regards to when they ask about extraction of iron, these four reactions are more than enough for you to obtain full marks. So for you to obtain full marks, write all the reactions and write all the states inverse. Then you are able to get the marks. But with simultaneously, keep in mind about this calcium carbonate process also, because sometimes they might ask you in a question, uh, what is used to make road surfaces. Then simple answer is what? Calcium silicate. Okay, so there are certain questions that they can ask you. So keep all this in mind, whatever I have told you. All right, then let's go to the next one. This is a process called rusting. Okay, so rusting is basically a process that you all have must have seen. So metals, especially iron, metals are not, most specifically they are iron. They will you will see a brown color, a rough brown color surface will form in certain metals. So why does this happen? What is the reason? Okay, there's a reason. There is a chemical reaction that happens. So when this iron it reacts with the oxygen and the water in the atmosphere, it is able to produce uh, iron oxide. This iron oxide is that brown color layer that forms as rust. Correct? Simple. Okay. So whenever you see this rusty, that red brown color, you know now as chemistry students, they are nothing. That is not nothing. Not a magical thing. It is a chemical process and it's a chemical product that has been formed. All right. Then can we stop? Can we completely stop rusting? No, we can't. But we can take measures that will prevent it. That means for certain times, for certain, so basically you can't put a full stop and stop it. You can't do that. But you can take certain measures in order to maybe prolong the time a metal will rust. Okay. So one thing that you can do is, which we call as sacrificial protection, we can apply paint or oil onto the iron body. So what happens then is, these without we exposing the iron to react with the water and oxygen in the atmosphere, we are exposing this paint or the oil. So it gives a protection coating. All right. And there is another special technique called galvanizing. So galvanizing is basically you're rubbing an element onto the iron, rubbing a very an element which is higher in reactivity than iron. You're rubbing onto that iron, and you, so in that case, what will happen? Because that element is more reactive, it has more tendency than iron to react with the water. Okay, so in that way, it will also stop rusting or prevent the iron from rusting. But these are, as I said, you can't stop, because now, for example, if we apply paint also, after some time the paint will also scale off and then the iron will be exposed. Okay, similar to zinc. So all these techniques do not stop rusting, but definitely it will uh, pause the process of rusting. All right. Then we come to the other extraction process that we are supposed to discuss in this is extraction of aluminium. Okay, so extraction of aluminium, as you remember from the reactivity series, it is in the top portion of that reactivity series, and any element in that top portion from potassium to aluminium, we need to use the process of electrolysis to in order to get the metal. So we perform the electrolysis, and into this, so electrolysis basically is the vessel that we used, that we will use, and into this vessel we as we put this uh, substance called bauxite or aluminium oxide. Okay, so the chemical name for aluminium oxide is bauxite. Okay, so this bauxite is the aluminium ore. Okay, that is found in nature. So we will use that, and we are going to electrolyze that. So with electrolysis techniques, we will be able to separate the aluminium and the oxygen separately. Okay, but into this vessel we also had a certain another substance called the cryolite. Okay, cryolite. Why do we use this cryolite? Is because this aluminium oxide has a very high uh, melting point. So cryolite, it reduces the melting point. So it makes this process more efficient for us. All right. So let's talk about the process now. So you need to remember that there will be basically two reactions that you need to remember. A reaction will take place at the anode. A reaction will take place at the cathode. What is this anode and cathode? If, to remind you again, cathode is the negative terminal. Okay, anode is the positive terminal. If you go back to this diagram, so you can see here positive. So these are the positive terminals. All right, these are the negative terminals. Okay, so this will be the positive, this will be the negative. Okay, so here we go. So anode, so this is the reaction that happens at the anode. The oxide ion will, what will happen? It will oxidize to form oxygen. Whereas at the cathode, okay, aluminium ions will reduce into aluminium. So cathode, you will find reduction. Anode, you will find the oxidation. All right. And then you will find the overall reaction. So these are basically, these are two ionic equations. We basically combine them together. Okay. So the way you can combine these is multiply this by 3, multiply this by 3. Okay, in order to cancel out the sorry, multiply this by 3, multiply this by 4 in order to cancel out the electrons, and then simply you have to add the 2, and that's the way you get this. Okay, so try writing the overall equation on your own and see whether you are able to get this answer. All right, so that is the, this is the thing that you need to know with regard to the extraction process of aluminium. Not very difficult, right? You need to remember only two equations. So overall, you have to remember three equations. Okay, not a very difficult task, right? Now, aluminium is a metal that we are able to combine with different metals and obtain a product, and with that we are able to use them into certain daily tasks. Okay, so not only aluminium, but there are plenty of metals in this world that we will combine with different metals and obtain a product to do a certain task. Simple. So when we when a mixture of metals, when we combine a mixture of metals, we call them as alloys. So definition of alloys is a mixture of metals. So when these alloys are formed, okay, the physical properties change. For example, the strength definitely increases, and also the resistance to rusting increases. Okay, so that is the main reason why we will use these, and we will look at certain examples uh, alloys. Okay, so certain examples are, for example, brass. So you know there are certain very ornamental things made out of brass. So brass, the combination of copper and zinc, 70% of copper and 30% of zinc. Bronze, bronze metals you might see, that is also a combination of metals of copper 15% and tin 85%. Mild steel, so mild steel is used for these washing machines and stuff like that. So that is also a combination of 99.7% iron and 0.3% of carbon. Then stainless steel. So stainless steel, where do we use stainless steel? In operation theaters and stuff like that, we use stainless steel. So stainless steel is also a combination of iron, chromium, and nickel in those given percentages. So do you need to remember these percentages exactly? No, you don't need to remember exactly. For example, now here, if you see 99.7, if you roughly say 99, you are good to go with. But remember what these alloys are made up. Very, very important. Okay. And remember, these are alloys: brass, bronze, mild steel, stainless steel. They are examples for alloys. So if anyone comes and tells you that bronze is a metal, then he is wrong. Bronze is not a metal. Bronze is an alloy. Why? Because it is a combination of copper and tin. All right. So with that, we come to the end of this video. So in this video, we discussed about the extraction techniques, how elements from copper, from potassium to aluminum can be extracted, from carbon to zinc, how can they be extracted, and then also from copper to gold, how they can be extracted. And in detail, we discussed about extraction techniques with regard to aluminium and iron. And also we learned about uh, application called rusting. Okay. And at the end, we learned about alloys, and we discussed about examples for alloys. Okay. So with that, we come to the end of this video. So please go through these video over and over again, and you will be perfectly ready to answer the assignment based on this topic. Okay. I will meet you in another video. Thank you for listening.